Hi Chem students, it's Miss Horn and welcome to a new unit over nomenclature, also known as chemical names and formulas. This is chapter 7 in your textbook. In this unit, we will learn to name and write formulas for ionic molecular compounds as well as acids and bases. This is a reminder to take notes as well as pause the video and rewind it as you need to. So first we need to talk about element categories on the periodic table. In order to be able to name and write formulas for chemical compounds, you must be able to classify them first. You will need basic knowledge of the types of elements on the periodic table to do this. So there's 3 different types that we're going to talk about. First, we're going to talk about the metalloids. So metalloids have both properties of nonmetals and metals. The metalloids on the periodic table are boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. They're the ones that you see here in purple. Things to the left of that are mainly metals, and things to the right of that are nonmetals. So our metals are in yellow and our nonmetals are in green. Be careful not to color hydrogen yellow with the metals. It's an exception. Hydrogen is a nonmetal. So take a moment to pause the video, take a snip of this periodic table, or even color your own. So some things about metals, nonmetals, and metalloids. Metals are elements that are shiny and good conductors of thermal energy and electric current. They are malleable, which means they can be hammered into thin sheets, and ductile, which means they can be drawn into wire. Iron has many uses in building and automobile construction. Copper is used in wires and coins. Nonmetals, on the other hand, are elements that are dull, meaning they're not shiny. They're poor conductors of thermal energy and electric current. Solid nonmetals tend to be brittle and unmalleable. Few familiar objects are made of only nonmetals. The neon used in lights is a nonmetal, as is graphite, which is carbon used in pencils. As for metalloids, also called semiconductors, they are elements that have properties of both metals and nonmetals. Some metalloids are shiny, while others are dull. Metalloids are somewhat malleable and ductile. Some metalloids conduct thermal energy and electric current well. Silicon is used to make computer chips. However, other elements must be added to silicon to make a working chip. In addition to the element categories that we've talked about, you will also need to be familiar with the charges of simple metals and nonmetal ions. An ion is a charged particle that forms when an atom loses or gains electrons. Atoms lose or gain electrons in order to become more stable, less reactive. We will go into more detail in this later. Remember that atoms are neutral because the number of protons equal the number of electrons. When an atom loses electrons, this results in a positively charged ion called a cation. Notice how I have the T here in red. And the reason is because the T in cation looks like a plus sign. It can help you remember that cations are positive. When an atom gains electrons, this results in a negatively charged ion called an anion. It's really important that you remember that. For example, sodium atoms, they have 11 protons and 11 electrons. If a sodium atom loses 1 electron, its charge will be plus 1 because it then only has 11 protons and 10 electrons. So because we have an extra proton or 1 more proton than electron, this gives us a net positive 1 charge. So let's look at some other ions. Sodium, for example, will be charged plus 1. So this means that it has lost 1 electron. If you look on your periodic table, you'll notice that sodium is a metal. Then we can look at chlorine. Since it's Cl minus, that means it has gained 1 electron. If you look on your periodic table, you'll notice that chlorine is a nonmetal. Magnesium, if it's 2 plus, this means it has lost 2 electrons. It is a metal. For nitrogen, -3, that means it has gained 3 electrons, and it is also a nonmetal. Oxygen, if it's -2, it has gained 2 electrons. It's a nonmetal. And aluminum will lose 3 electrons, and it is a metal. Hopefully you're noticing something here. Did you notice that the metal ions are all positive and the non-metal ions are all negative? So how do we figure out what the ion charges for the different elements are? Well, there's a pattern that exists on the periodic table. So if you look at my periodic table here, Group 1 elements, starting with hydrogen, have a +1 charge. Group 2 elements have a +2 charge. We're going to skip the transition metals right here for now. They are multivalent, which means they will have variable charges. Like at certain times they can be +1 or +2, sometimes +3, +4, etc. This column right here, starting with aluminum, tends to have +3 charges. The next column, starting with carbon, we're going to skip that because it's also multivalent, just like these transition metals here. Then we go to -3, -2, -1, and lastly our noble gases. They have 0 charge, meaning that they do not form ions, which means they're really stable by themselves. They don't like to bond with other stuff. So it's important for you to memorize this trend on the periodic table. So like we said, for groups 3 through 12 and 14, ion charges can vary with the group and even vary for one metal. For example, sometimes copper is +1 and sometimes it's +2. So we cannot assign a charge for these groups as we did above. There are more details to come. You must memorize the charges for these 3 ions. So you need to know that silver is +1, zinc is +2, and candium is +2 as well. So before we learn to name compounds, we need to be able to classify them, meaning we need to be able to tell the differences between them. There's 4 types we're going to talk about: ionic, molecular, acids, and bases. So let's start with ionic. Ionic compounds are composed of a metal ion first. Remember the ones that we colored in yellow, and then a non-metal second, the ones that we colored in green, joined by something called an ionic bond. Either one or both of these may be replaced by a polyatomic ion. Note, an ion is a charged particle due to the loss or gain of electrons. So examples of ionic compounds would be things like sodium chloride or something like calcium bromide. Notice that the first element is a metal and the second one is a nonmetal. Molecular, also known as covalent compounds, are composed of nonmetal atoms joined by covalent bonds. Metalloids may also be present in molecular compounds. So an example of these are things like CO2 and H2O, water. So carbon dioxide and water are covalent compounds because they are made up of 2 nonmetals, and like we said, sometimes metalloids can be present. The next thing we're going to talk about are acids. They're composed of a hydrogen ion followed by either a nonmetal ion or a polyatomic ion. So you recognize acids because they start with hydrogen and then there is something else. But the fact that they start with hydrogen is really important. So some examples are hydrochloric acid. You can identify it because it starts with hydrogen. Nitric acid, sulfuric acid, carbonic acid, acetic acid, and phosphoric acid. And then lastly, we're going to talk about bases. They're composed of a metal ion followed by a hydroxide ion. So the fact that they end with hydroxide identifies them. So we can have potassium hydroxide, or we can also have sodium hydroxide as 2 examples. Notice again that the first ion is a metal, and then the second part is the hydroxide ion, making it a base. One other base you need to know is ammonia, NH3. It does not have a hydroxide in the formula, but it produces hydroxide ions when it's mixed with water. Other bases do exist as well, but you're not responsible for knowing their names and formulas in this class. That is all for this video over how to classify and identify different compounds. I hope you found it to be helpful. For more help, you can go to our website, falconchem.weebly.com. Have a good evening.